Hi, welcome back. Once again, I'm welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. Now, I'm happy to announce that now Unacademy is going to providing online training for GATE and Engineering Service Exam. Now you can crack GATE and ESE with India's largest learning platform. About myself, I G Venkata Sir. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination, and at present, I am pursuing PhD from JNTU Kakinada, and my specialization is VLSI design. Now, here just we see how to get Unacademy learning app. Just go to Play Store. Now, type Unacademy. Then it will show the Unacademy learning app like this. By clicking on this install button, it will install the Unacademy learning app into your device. Now, this is very important. What you will get. So by joining Unacademy, what you will get? See, the first and foremost thing is daily live classes. You get every day there is a live class. Every day there is a live class. Okay, in that live class, you can chat with your educator and you can engage in discussions. You can ask your doubts and answer polls. So you can do all these things while class is going on. You can do all those things while class is going on. Okay, so chat with your educator. That means faculty. You can engage the discussions. So you can discuss with your faculty and you can ask the doubts and participate in polls. So you can perform all these things while class is going on. Next, structured courses. See, all our courses are structured in line with your exam syllabus to help you best prepare for it. Next, live tests and quizzes. So you can evaluate your preparation with our regular mock tests and quizzes and get detailed analysis on your performance. See, once you feel that your preparation is completed, now you can evaluate your preparation with our regular mock tests. Regularly we are going to conducting the mock tests and quizzes. By participating in that, you can get the detailed analysis on your performance. Okay, and next one is unlimited access. So once you take in a subscription, you can get your access to all our live and recorded courses to watch from the comfort of any of your device. All your courses, you get access to all your live and recorded courses once you take in a subscription, and you can watch any of your comfortable device, either laptop, desktop, tab, mobile, anything. Next, iconic subscription. There are two subscriptions, iconic subscription and plus subscription. In plus subscription, just before, what are the things I explained? Daily live classes, structured courses, live tests and quizzes, unlimited access. All these things you can get by taking plus subscription. Okay, and iconic subscription. In iconic subscription, what are the benefits? Just before we discuss the benefits get by the plus educator, plus subscriber, these benefits you get. In addition to this, you will get a personal coach, study tracker, and most important thing, mains question and answer practice. See, personal coach first. So you can get one-on-one guidance from top exam experts as your personal coach, and this personal coach is going to, we are providing a personal coach is a top exam expert. once you've written one exam you attempted or one quiz you attempted, we forward the data to your personal coach, that means that your exam expert. He will do the analysis on that, and they will prepare a proper study plan to you, and respect to material also they will provide. Okay, this is the function of the personal coach. And after that, you can evaluate your progress by weekly reviews with your personal coach. Okay, that is the study tracker. You can track your preparation, your progress by weekly reviews with personal coach. So for that, you need to participate in a study tracker plan and study boost workshops. And mains question and answer practice. Yeah, this is very, very important, my dear students. See here, mains question and answer. So you know it or not, in engineering service exam, you need to write one mains paper. In that mains paper, you need to answer the question. Okay, so to answer the question, the way how you are answering in your semester exam, the way of answering in semester exam, answering question, and the way of answering in engineering service exam is different. Okay, here complete concept is required. Okay, in engineering service exam, your question is completely depends on a concept. Okay, so you need to stress some points, you need to give more explanation required wherever required. So those things where you need to stress, where you need to explore, those things you get by regular practice. Okay, you can strengthen your mains answer writing through regular practice, and we evaluate that and give the personalized feedback to you. Okay, that is the important thing here. So these are the additional benefits you are getting with respect to Plus subscriber. That is about Iconic subscription. And yeah, so there is an Unacademy combat is going on once again. So this combat is going on in the month of April. Every Sunday in the month of April, scholarship test is there. Now the worth of scholarship test in the month of April is 3.5 crores plus. 3.5 crores plus. Now this is for GATE and engineering service exams. So these are the different departments: mechanical engineering, civil engineering, electrical engineering, electronics and communication engineering, computer science and IT departments. Already 18th is over. Next combat is on coming 25th, coming Sunday. The exam is at 11 AM. Okay, and the duration is 60 minutes. Don't forget to use my code VRAU10 during enrollment. Now, so these are the branches. Every Sunday at 11 AM exam, and exam duration is 60 minutes. Now, top 3 winners from each branch get a 100% scholarship on Plus subscription, and 100 winners from each branch will be given additional benefits like 70% discount, 75% discount, 80%, 50%, 25%, 30%, like that, different percent. Now, don't forget to use my code VRAU10 to unlock the test. Now, see, by participating in this exam, what you are going to be benefited. See this. It is the India's largest weekly scholarship test for GATE, and you can assess your GATE preparation in 60 minutes. Challenging and original GATE questions curated by the best educators here, and take it live to compete with the best, and super fast and fun with All India live leaderboard. So identify and improve your weak areas through detailed video solutions. So your next combat is on 25th. Starts at 11 AM. Okay. Here are the GATE 2021 rankers who benefited from GATE combat. Okay. Next. So now we are going to analyzing common source amplifier. Before going to common source amplifier, I am going to give the small signal model representation of a FET. And whatever the analysis we are doing on common source amplifier is basically for JFET. After that, we apply the same thing to E MOSFET, enhancement MOSFET, because that is the N channel enhancement MOSFET is the default MOSFET. We apply the same to E MOSFET. Okay. Now, first I am going to small signal model representation of JFET or FET. Small signal model representation of FET. You can apply this one to any FET, JFET, MOSFET, anything. Yeah. Already we observed whatever the drain current we have is a function of, with respect to VDS it is changing, with respect to VGS it is changing. We observed that function of VGS comma VDS. I am using Taylor series, therefore change in ID is, total change in ID is dou ID by dou VGS into delta VGS plus dou ID by dou VDS into delta VDS. Okay. Now here this dou ID by dou VGS is called transconductance. Okay. So dou ID by dou VGS is called transconductance GM. This is at delta VDS 0. Change in VDS is 0. And another way of, once it is 0, now can also written by dou ID by this one. So this is the transconductance GM. At the same time, here I am going to dou ID by change in output voltage, output current by change in output voltage is 1 by output resistance, small rd, drain resistance we call it. Okay, this is the value of 1 by dou ID by dou VDS. Here we need to take VGS common. These are the values. Now I am substituting these two in this. Okay, therefore delta ID equal to dou ID by dou VGS is GM into delta VGS plus dou ID by it is 1 by RD into delta VDS. Okay, now this is our equation. Now, see this? Now, here delta ID is change in, small change in drain current ID. I am calling it as small ID I am representing. And delta VGS is small change in VGS. Which is small VGS. And delta VDS is similarly small change in VDS, capital VDS, that is small VDS. Now I am writing these things here. Therefore, ID is, small ID is GM into small VGS plus 1 by RD into small VDS. This is the final equation. Okay, now we are going to using this expression. Now I am going to representing this equation by and its equivalent circuit. Okay, so from FET we know that gate current is 0 always. So this is the gate terminal, source, this is the source, and your ID is defined as, let us take it is I1 plus I2. I1 is a GMVGS. It is a dependent source, dependent current source. GMVGS. This is the, and here is RD. This is RD, and drain it is source. The voltage between these two is VDS. This is the drain current ID. Here IG is 0. That's why it is open circuited. And voltage between these two is VGS. This is the small signal equivalent of FET. Okay, and in this, we are considering RD in this sense. There is a channel length modulation concept we are applying mostly in MOSFETs. While discussing about MOSFETs, there we use channel length modulation. We considered by considering channel length modulation, by omitting channel length modulation, how we can change the device. We discuss about those things in that. And after that, with respect to that, body effect also is there. By considering body effects, its model is different. By omitting body effects, its a different model is different. Those things we discuss in detail in MOSFETs. Okay, now this is the small signal representation of the JFET. Okay. Small signal equivalent of JFET. Now, I'm going to, the way how we replace BJT, it's by its approximate model or H parameter model or R pi model. The same way you can replace, you can take the MOSFET, JFET common source amplifier, take the AC equivalent, after that replace that JFET by its small signal equivalent. Now I am going to common source amplifier. Common source amplifier. Common source amplifier. First I am going to circuit diagram as usual. First I am taking the FET test. So voltage divider bias I am going to taking. So it is properly biased FET. Plus VCC, sorry, plus VDD because it is a FET. R1, R2, it is a capital RD drain resistance and it is the source resistance RS. And here I am going to applying through capacitor, I am applying input. Okay, let us take Vs. I am neglecting the Rs. Why? Because here source resistance. Because already at source terminal of the MOSFET, JFET, we have source Rs. Let us take it as Vs. And common source we are taking at source is connected to ground through a capacitor, because it is common source amplifier CS. At here I am taking output. This is a CD. Okay, and this is Vs. The same circuit, sometimes they will provide the same circuit like this. Sometimes they will provide the same circuit like this. RS, sorry, RG. Here is input. Okay, like this also sometimes they will provide. Okay, you may consider this capacitor or not, it's not an issue, the simplified one. Okay, now but we concentrate on this circuit. This is the standard model. After that we take this type of models and we analyze those things also. This is the common source amplifier circuit. Now first I am taking the AC equivalent circuit of this, because we are going to calculating all the parameters: input impedance, current gain, voltage gain, input impedance, and all those. Now first I am writing AC equivalent circuit. AC equivalent circuit. For AC equivalent circuit, what we have to do is all capacitors has to be short circuit, and after that external source, what we have, that external DC supply connected to ground. Okay, so I'm taking equivalent circuit. See this? Now all DC sources, all external capacitors are short circuited, and VDD connected to ground. Okay, this is the next level of circuit. Now drain connected to ground through RD and source directly connected to ground, because RS is bypassed by CS, by a short circuiting of CS, and at input we are applying Vs, as well as R1 parallel with R2. I am taking that R1 parallel with R2 as RG. Okay, by applying all this on this circuit, now the resultant circuit is, or final circuit is like this. So is a drain, source, and gate. This is the simple way to draw the AC equivalent circuit. You can apply the same thing to any of your amplifiers. For common source, I am taking source at input side, common side. Now source is connected to ground. At gate, I am connecting RG. We can consider it as an input biasing resistor. At RD, drain, you are connecting RD to ground. That's it. Okay, RD to ground. Now here you are applying input. You can take V in or Vs, it's not an issue. Here we are taking output. Okay, now we know that this is the drain current ID, small id. Now current through this also small id, drain current, because it is nothing but a source current equal to drain current, and gate current is 0. Now I am going to replacing this JFET by its small signal equivalent. Small signal equivalent of JFET is gate, source, small RD, GMVGS. It is the drain, it is the source, it is the gate. The applied voltage is VGS, small VGS, and this is the drain current ID. Now, see this source connected to ground. Okay, source connected to ground, fine. Drain connected to ground through RD. So, drain connected to ground through capital RD. Drain connected to ground through capital RD. Okay. And after that, gate connected to ground through RG. Here you are applying input voltage. Okay. And here we are taking output. So once it is ID, this is going to be minus ID. Okay. Now, see this. This is your VG. Your VG is nothing but a input voltage. From this circuit, input voltage is nothing but a VGS, and output voltage is minus ID into capital RD. Minus ID into capital RD. Okay. So now I am going to apply the analysis on this. Series. And we know that this is the input current, II is IG, which is 0. This is the input voltage. Now, first one is current gain. AI is minus ID by II. That means IG is the input current. So, minus ID by 0, which is infinity. So, current gain is infinity. Current gain is infinity. And next one is input impedance, RI. Input voltage by input current. So input voltage is VGS by input current is IG. So which is VGS by 0 infinity. Current gain also infinity. This is the current gain. Sorry, input impedance infinity, RI. And here we can take effective input impedance, RI dash. Therefore, Ri dash is Ri parallel with Rg. So, infinity parallel with anything is the same thing, Rg. That is about input impedance. Next, third one is voltage gain. Voltage gain. Voltage gain, which is output voltage by input voltage. Output voltage means this one. The voltage between drain to source. Now, if you observe one thing, we can rearrange the circuit like this. Small RD parallel with the capital RD, capital RD. Now this current is GMVGS. So GMVGS current is flowing into this. And the voltage across this one is small VDS. It is nothing but your output voltage. Therefore, output voltage is VDS equal to, it is VDS by VGS equal to minus of GM VGS into small RD parallel with capital RD. GM VGS into small RD parallel with capital RD. Small RD parallel with capital RD. Now I am taking this VGS this side. VDS by VGS is minus GM transconductance into small RD parallel with capital RD. That's it. That is the voltage gain. That is the voltage gain. Okay. Now after that I am going to calculating the output impedance. So for calculating output impedance, I am taking the circuit by disconnecting capital RD. Okay. So next one is output impedance. Output impedance is the voltage between drain to source small VDS by RD, VDS by RD ID at a condition of V input or Vs equal to 0. Now Vs is 0. This is 0, means short, grounded. Input 0. It is grounded. Once it is grounded, then input voltage equal to 0. That means VGS equal to 0. So once VGS equal to 0, therefore V input equal to 0 means it results VGS equal to 0. V input equal to VGS equal to 0. Now once it is 0, from this whatever the GM VGS we have, it became 0. That means this current source is 0. This current source is, it is 0 current. This now it should be open circuit. Now the equivalent circuit is, that's it, small RD, it is VDS, current is ID. This is the equivalent circuit. Here it is open circuited. Now therefore VDS can be written as ID into small RD. Therefore output impedance is VDS by ID, that is RD. That is the output impedance including load, that is R naught dash, that is small RD parallel with capital RD. Whatever the capital RD here we have, just this is the RD, R naught. Here we are adding by adding RD, capital RD. It became R naught dash. That's it. Okay. So far, what are the component? What are the values we got? Is first one is current gain. We got current gain is infinity. Second one is input impedance infinity, and Ri dash is Rg. Rg is nothing but a R1 parallel with R2. Third one is voltage gain. Voltage gain AV is minus GM into small RD parallel with capital RD. And fourth one is output impedance is small RD, and R naught dash is small RD parallel with capital RD. Okay, these are the components, these are the values. Okay. So these are the values. This is your common source amplifier. Now, the same thing we are going to discuss in the view of common source stage we take by using JFET, sorry, MOSFET, N channel enhancement MOSFET. Okay, now CS common source stage with the E MOSFET. N channel is a default. Now, the simplified circuit is like this. Source connected to ground because it is common source. At the drain we have RT. Here we are applying VDD. This is the drain, capital RD, drain resistance. This is the gate terminal. At gate terminal I am going to applying V input. This is a enhancement MOSFET. Okay, enhancement MOSFET, and here we are taking output. V output. Okay, now in this circuit you can replace this one by its MOSFET small signal model also. Now the small signal model of this one is like this. So this is a V input. Let us consider this is a voltage I am applying is V1 or VGS, and source connected to ground. Here we have GM into VGS. VGS is nothing but I am representing that one by V1 to V1, and here is output. At load we have RD, capital RD acting as a load. This is the CS small signal equivalent by omitting channel length modulation. This is the equivalent of this amplifier by omitting channel length modulation. Okay, so this is by omitting channel length modulation. Channel length modulation. See this, how simple it is. Now we can easily calculate that by omitting channel length. It is a drain, we know that. It is a gate, it is a source. This is ID, this is minus ID. Now ID is from this, ID is GM into V1, and output voltage is minus ID into RD, capital RD. Now it is minus GM into V1. Here V1 is nothing but a V input. So into capital RD. Therefore V output is minus GM into capital RD into V input. Therefore, voltage gain is V naught by V output by V input, which is minus GM into RD. See this, in terms of transconductance we got GM into RD. Now, what is the transconductance value for E MOSFET? First we should know that. Therefore, voltage gain is minus GM into capital RD. Okay, and by considering channel length modulation, the equivalent circuit is like this. Here is V input, this is V1, here is GM VGS, sorry, GM V1, small rd is there. The small rd is going to R0 or RD, we can call it anything, is going to represent the effect of channel length modulation, presence of channel length modulation. Previous case in JFET we called it as RD, small RD. Okay, it is the drain, here is capital RD, this is ID. Now this is nothing but a, previously we used this one is small RD, and this is a VGS, this is the gate, source, it is the drain terminal. Now we can write directly from this by considering channel length modulation gain is minus GM into capital RD parallel with small R0, output resistance we called it. So minus GM into capital RD parallel with small RD, whatever it is. Now, what is the transconductance value for MOSFET, E MOSFET? See, here our intention is to use MOSFET as an amplifier, and it is acting as an amplifier in saturation region or pinch off region. So therefore, E MOSFET is acting is E MOSFET works as an amplifier, in saturation or pinch off region pinch off region. Therefore, in pinch off region, ID is or IDS is, you can take either ID or IDS as you wish. Okay, is mu n into COX into W by L by 2 into VGS minus VTH whole square. This is the equation. Now to get the transconductance, so GM is dou ID by dou VGS. Just differentiate it with respect to VGS. So it is a mu n into COX by 2 into W by L into 2 into VGS minus VTH into 1. So here this 2 and this 2 gets cancelled. Therefore GM is mu n into COX into W by L into VGS minus VTH. This is one equation. And another equation I want to get, because from id equal to mu n cox into w by l by 2 into vgs minus vth whole square, we can write vgs minus vth is, we can write this one is 2 into capital id by mu n into cox into w by l square root. Now, in place of this, just substitute this. Therefore, Gm is mu n into cox into w by l into square root of 2id by mu n into cox into w by l. Therefore, final value of transconductance is square root of 2id into mu n into cox into w by l. That is the final value of the transconductance. Okay. Now, therefore, voltage gain is, we are representing voltage gain is minus Gm into capital RD by omitting channel length modulation. Just to substitute the Gm value, minus of square root of 2 capital ID into DC drain current, sir, it is mu n cox into W by L into RD. That is the voltage gain. Okay, sir, that is the voltage gain. Now, here I am going to discussing about one more important topic. So for that, I am going to take the circuit diagram of previous one what we discussed. See this. Now, this is VDD, RD. This is V input, and here we are taking output. It is V output. This is AC circuit. Now, in DC point of view, let us capital ID is flowing to this. Now, the voltage between these 2 points is VDS. We can write from this VDD equal to, just I am applying KVL to output loop, not more than that. KVL to output loop. By applying KVL to output loop. VDD equal to ID into RD plus VDS. Okay. Now, from this VDS is VDD minus VDD minus IDRD. Okay, this is the VDS value. Now, the condition to work MOSFET as an amplifier is it should be in saturation. So therefore, MOSFET, E-MOSFET should be in saturation. Should be in saturation. should be in saturation. For that, VDS value should be greater than or equal to VGS minus VTH. That is the condition required to operate to work your MOSFET as an amplifier. And from this you are saying VDS value is this much. Now I am taking this and substituting here. Therefore, VDD minus IDRS, IDRD, sir, IDRD IDRD is greater than or equal to VGS minus VTH. Okay, now I am taking this IDRD this side and this one this side. Therefore, IDRD is less than or equal to VDD minus VGS minus VTH. So this is the condition on RD to work it as an amplifier. Okay, by using this type of equations, you can measure the required value of RD to operate MOSFET as an amplifier. Okay, such type of things you can easily calculate. Okay, so this is the analysis of E MOSFET in common source. After that, you can replace, you can connect this one to source here, current source you can connect, or you can connect a degenerative resistor. Like that, we can add some additional things to that. So next session we discuss about all those things. Okay, thank you. So sorry sir. Now here are the few of the top educators from Unacademy. Tiwari sir, he is the IIT topper and he has 7 years of GATE and ESE teaching experience. Ankit Goyal sir, he obtained All India first rank twice in GATE Electrical and he was awarded President of India Gold Medal in IIT Indore. Sanchit Jain sir, he is the computer science faculty having a teaching experience of more than 8 years. And next, Jaspal Singh sir, he is ex-IAS officer, he got All India 4th rank and he is a scientist, GATE, State Service Exams and PSU topper and ex-senior GATE ESE faculty. Now here are the few of the top educators from Unacademy. And in GATE and engineering service, these are the different engineering disciplines available in Unacademy. So ECE, electronics and communication engineering, and chemical engineering, mechanical engineering, computer science and IT department, instrumentation engineering, electrical engineering, civil engineering, production and industrial engineering. Now there are two subscriptions, plus subscription and iconic subscription. In both the subscriptions, India's best educators are handling your subjects. Interactive live classes are there, structured courses and PDFs, and live tests and quizzes. Now here we are going to show the difference between plus subscription and iconic subscription. In iconic, once you've written the exam, your paper is forwarded to your personal coach. He do the personalized test analysis on that. Based on that, they prepare a study planner and they provide respect to study material also to you. By following these two, every student can get success in their examinations. There are two types of subscriptions, plus subscription and iconic subscription we discussed already. In plus plan, there are different subscriptions: 1 month subscription, 3 months, 6 months, 1 year, 1.5 years and 2 years. Now here the beauty is EMI option also available. Okay, and By using my code VROUT10 during subscription, you can get it by 10% discount. Okay, if you take for example 1 year subscription, by using my code VROUT10 during subscription, you get it by 10% discount at 27,225 rupees only. And in Iconic plan, 2 subscriptions, 1 year subscription and 2 year subscription. For 1 year it is 50,250 rupees. By using my code VROUT10 during subscription, you get it by 10% discount. Okay, and so don't forget to use my code VROUT10 during subscription. Please give your valuable comments on YouTube, subscribe us, hit the bell icon for getting notifications, join our Telegram group for getting latest updates on our upcoming videos. Okay, and thank you very much. Sorry, thank you very much. Thanks for spending your valuable time with us. So once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Thank you.